So for our second day with inequalities, we're going to be graphing two variable inequalities. What that means by two variable inequalities is exactly in the name. We have both x's and y's. So in our equations before, we just had one or the other, and when we solved it, the answer was x is less than 2 or whatever. Now that we have two different variables, we're going to have more of a statement where it's like y is less than 2x or x is less than 3y or whatever like this. Because of that, we have to graph them on a coordinate plane. So because of two variable inequalities, we are now working on coordinate planes. Two variables means that we have two answers, which are ordered pairs, x and y, which goes with coordinate planes. So when we look at our inequality, first thing we should know is our similarities to the form slope-intercept form. The only difference is we do not have an equal sign, we have an inequality sign. Because of the inequality sign, we're going to be using either a dotted or solid line. Dotted are our two symbols without the equals. Solid are the ones with the equals. We graph this one the same exact way. So we start down 4, then down 1, right 1. Then this particular line, because it's equals, is a solid line. And normally, if this was just an equation, this is where all the potential answers are. Because it's inequality, there are more than just these answers. To check, we take the equation from its exact form, and we're going to plug in some point that isn't on the line. It doesn't matter which point you get, it will tell us the same information. I always pick 0, 0 to be my test point, as long as it's not on the line. So we're going to test 0, 0. When I plug it in, y is 0, x is 0, so I have 0 is greater than, well, that disappears right here, -4. I now check this statement to see if it's true or if it's false. Is 0 greater than -4? The answer is true, meaning this point works. So we are going to end up shading the entire region above our line. Like so. If we had picked a point and it did not work, say this point right here, -4, -4, okay, so I have -4 is greater than or equal to -4 minus 4. I get -4 is greater than or equal to, that becomes a positive, that becomes 0. Once again, true or false? Well, -4 is not, so we have false here, meaning this point does not work. We do not shade it, so we shade the other side. Let's try another one. This time it's in standard form, so we have to do a bit of converting. First thing is I'm going to subtract both sides by negative 3x. I get negative 4y is less than negative 3x. Remember, we only flip the symbol when we multiply or divide by a negative. I am going to divide by a negative 4. Therefore, our inequality symbol has to switch, and I have y is greater than 3/4 x. We start at 0 because there's a plus 0 here. Up 3, right 4. Down 3, left 4. Whoops, too far. We need a dotted line in this case because it is just a, well, greater than now. It was a less than to begin with. Now we have to pick a test point. We cannot choose 0, 0 because it's on the line. Can't even choose 1, 1 because that's possibly on the line. So I like to pick a point that's clearly not on the line. It could be anywhere. I'm going to pick this point right here. 0, 3. So 3 goes in for y. 0 goes in for x. To get 3 is greater than 0. We ask the question, is that true or is that false? 3 is greater than 0. That's true. So we end up shading everything above the line. The second part following that was, what if we had a system of these linear inequalities? So we take them one line at a time. This first one I'm going to graph in red. Starts up 2. Then I have to go up 5, right 3. I can't do that, so I have to go down 5, 1, 2, 3, 4, 5. Left 3, 1, 2, 3. The exact opposite of what I wanted to do. It needs to be a dotted line. And now we're going to do an initial check to see which way it's supposed to be shaded. Once again, I'm going to pick 0, 0 as my test point. So 0 goes in for y. 0 goes in for x. And I get 0 is less than 2. Once again, that is true. Now that I'm working with a system, I'm not actually going to shade. I'm just going to put these lines like this to tell me that I'm going to end up shading below this line. This makes our life a lot easier later on. Because I could, now on my computer, if I were to go through and actually shade, oops, fixing my line a little bit. Dang it. There's my line. I could use this highlighter option. Use 2 different colored highlighters. You can see where they overlap. Now, unless you guys are also working on the computer, I would suggest doing the line option first. That way you don't shade and it's harder to see the lines in the areas you're supposed to shade. So I'm going to do both kind of simultaneously. For the line, I'm going to use green. Starts down 2, and then goes up 1, right 3. Up 1, right 3, can't do that, so down 1, left 3, right there. It's a solid line, like this. Once again, I'm allowed to pick 0 as our test point. 0 is greater than or equal to 1/3 times 0 minus 2, so is 0 greater than or equal to negative 2? That is true. We would shade above this. So then, using just the lines, you see where the 2 areas would shade, and you'd be right here. I'm going to use a different color highlighter. There it because that's the one I want. I'm going to use my light blue here. And so wherever they intersect would be the area that you'd want to concern yourself with. So wherever the highlighter ends up being green is my solution set. Over here the light blue doesn't matter, the yellow doesn't matter, it is where it ends up being green is where we'd want our solution set. Let's try another one. Once again, in both in slope-intercept form, so we're good to go. First one, we go up 3 to start, then we go up 2 ray 1, down 2 left 1, down 2 left 1, down 2 left 1. It is a dotted line because of the less than symbol. Plug in our test point 0, 0 is 0 less than 3. That's true. We'd want to shade this below. Kind of like the color changing aspect of that, so I'm going to use my yellow highlighter and blue highlighter again. Okay, our second line. We start down 1. Then we go up 2, right 3. Up 2, right 3, can't do that, so we go down 2, left 3. There's an intersection point. That doesn't matter as much in equations. This one's actually a solid line. Using my test point 0, 0, I get 0 is less than or equal to negative 1. Well, that's false. So we would shade below. Where the two shadings overlap would be our solution set. So where our colors are changing from yellow and blue into green is our solution set. Granted, even down here would still be the answers, continuing on forever in this direction. And that's graphing systems.